Welcome to SimNation's Quick Look, where we take a look at a game that we believe you're gonna find interesting. And as always, even if the video is long, we're gonna show you everything you need to know in the first minutes, and then the rest is for you just stay and hang out if you want. So, we're looking at right now here at Universe Sandbox 2 or Universe Sandbox Square. It's not necessarily a game, but I will be calling so in the rest of the video, because there's no achievements or goals or objectives or anything like that. It's more like a sandbox. That's what it is. It's a simulation of the universe, and it's really well done. Right now, you can see that the simulation is running at 15 days per second. It is simulating everything that it needs to simulate about these planets, the relations between them, the gravity, and so on. At the speed of 15 days a second. That is awfully fast. The way it's doing it, let's slow it down a little bit and let's find Earth. We know that guy, right? So right now I'm simulating at 1 hour a second. Here's Earth. You can see it's moving at 1 hour a second, pretty much 1.22 hours a second. There's no way to actually make it like super precise. You know, if you want to say, actually, wait, look at that. Oh no, fixed. No, there's no way to actually pinpoint the exact speed you want it, so you have to, you know, do it more or less. But okay, this is more or less an hour a second, right? You can see the Earth spinning. If I made it 24 hours a second, it would spin a whole cycle every second, 24 hours. Makes sense. You know that, right? You can see it's moving around the sound. Everything is being simulated. But what is really interesting about this is not just to, you know, it's not an Encarta that is pretty. Not at all. This actually simulates everything. And let me quickly show you that. Well, first of all, you have the mass, radius, and density, which are, of course, bound, as you would expect, of a planet. You got the age, the temperature, the velocity, the relative velocity, the relative body, in this case, the sun, an orbital parent, the same thing. By the way, I don't know that much about physics. I know some, but not too much. So I apologize if you're a physicist or you teach physics or you just happen to know about physics because you're a hobbyist. Yeah, sorry about that. But I will try to do my best here. I do know some. Then of course climate, in the case of this planet you can actually play with the climate. Also the materials, you can do all sort of things. You can even increase the amount of hydrogen in Earth. And now I made it a gas giant. That's simple. Okay, I turn it back, but yeah, it's not that good still. We're gonna. Okay, I remove all air in Earth. Okay, I tend to destroy Earth fairly often in this game. Again, and surface temperature. It's all right. And actions, you can do a few little tweaks here and there. Anyways, like auto orbit and so on. In case you want to make something snap back to orbit. Anyways, what is interesting about this? Well, that you can play with things. You can do all sorts of things. Like an example, have you ever wondered what happened if we had, I don't know, 2 suns? Let's figure it out. Let's go add, and we pick a star, and let's just add another sun, like the sun we know. And we're gonna add it, what if we added, I don't know, about here. We're gonna make it still location, and here, there we go. Now we have 2 suns that they're quite widespread, and we're gonna speed up the simulation, and okay, we just made this planet, which, by the way, you can see the hydrogen just like zoom in. See the hydrogen just leaving the planet. Because of the temperature, that is all being simulated. That is all being simulated. There is no hydrogen anymore, and that's made to water. Okay, we may need assistance to make this video anyway, and yeah, that's completely off orbit. That just, and then we can see we're actually making suns reach each other, and the whole very like we're in a solar system that is so fragile. I mean, if something ever changed, we're screwed. We're so screwed. Look at this. At 10 hours a second, look at the speed of this sun going. Look at the velocity. 40 kilometers a second. let me slow that down for you. You can what is really interesting that you can click on things and you can ask for, say, a mass. You get stuff like, you know, kilometers and so on, but also you get like the sun, which, you know, the sun is 1 times the mass of the sun. But you can also use the moon or Earth as a unit, which is great because it is stuff that we know. This is huge. That is very important that they did this. In this case, we can see that the sun is like over 300,000 times the Earth in mass. Okay, not in size, in mass. In radius, it would be 110 times more. In density, well, we cannot do that. Anyways, these two are gonna collide. Oh my god. Oh my god, they're gonna collide. Oh no, I destroy Earth and everything around it. And what is it, like 5 minutes of the video? Oh, damn it. Oh, and we just made a supernova. Yep. So you can see Earth right here, and it's not doing great. It's not doing great. Let's check on the temperature of this guy. By the way, the speed right now is only a few minutes a second. We're gonna reduce the accuracy. That's gonna help with my CPU. We're at like a minute a second. A minute a second, and where's the temperature of Earth right now? 30 degrees Celsius surface temperature. Oh, it's rising. Everybody's boiling in Earth right now. We're gonna speed it up a little bit. We're gonna keep watching Earth, but we're gonna be zooming out. Look at how beautiful. Okay, look at Earth. Look at Earth. That's it. That's it. Over 4,000 Celsius, 5,000, 6,000, all in a matter of like minutes. That's what would happen if the sun collided with another sun. In minutes, it would all be gone. That is how fast this. It's not like a process that takes years. No. This is like so much energy. Look at. It's pretty much like another sun. The Earth is like another sun right now. It's at almost 20,000 Celsius. 20,000. You can plane at 30 something Celsius. This is 20,000. For you to get a perspective on that, and we can actually just speed it up, and we're gonna reduce the accuracy because. And yeah, let's just speed it up. And we're like right now at 5 days a second. This is all happening at 5 days a second. Okay, the Earth is right now at minus 200, almost minus 300 Celsius. It's barren. Earth is gone, right? So it burns and then there's nothing left. This is expanding at an insane speed. It's just an insane speed. I have no way to measure it, but just to like, we're like down there, or like down here. This is Earth in the middle of this very scary, by the way, very scary. Oh shit, that scared the crap out of me. Sorry. The universe just really scares me because it's nothing in nothingness, and then you get stuff like that. Anyway, and yeah, we're in the middle of that nebula, and it's still growing. Let's speed it up again, and wow. Well, okay, we're now going at 9,000 years a second, and it took about what, 20,000 years to do that. Okay, that wasn't much. 25, maybe 15,000 years. Yeah, but you know what is really creepy? Well, you know what, it's super creepy, and we're gonna go to experiments in just a little bit, but just for you to get a better sense of like just how creepy space is. Look at this. We're gonna slow down the simulation to like nothing. I mean, if nothing like this, I mean, already scared you off. Let me pick a planet like Jupiter. Look at this. Look at the size of Jupiter. We're nothing. And Jupiter is not like a huge planet. Not at all. Like, let me pause the simulation for you for a second before like I destroy everything again. This is Jupiter right here, right? Look how huge it is compared to us. And for us, the Earth is so big. No, nothing. You want to see something even scarier? Look at not the sun. Like the sun. Look at the sun. Look at the freaking sun. That is huge. We're like at this tiny little bit. No. You want to see something even worse? Look at a huge star. Like, I don't know. Like this one. Aren't you scared of looking at this? Like, look at the tiny little particle we are in the universe. By the way, if I press play here, I don't even wanna, because but just for you to get a sense, okay? And the good thing is that you can tweak all this. You can tweak planets. You can change their mass and radius. You can make this, you know, 100 times the sun, if I want. I can make all sort of things. I can, well, change the, oh, I can change the age. And what if I make this? Okay, I should have studied a little bit more of this before I dig in. Let's just multiply this by 10, basically. So, oh, okay, supernova. So we're not that far from a supernova, as you can see. We're gonna put another one. Okay. Oh no, now we are okay. Supernova going on here. Okay. Yep. Not that hard to make a supernova here. Okay, actually, there are experiments you can do, and that is where it really gets interesting. Because I mean, you have, first of all, I mean, we're gonna get to all the experiments in a little bit, but it's at home. Sorry. You click open, and then you see all the experiments and solar systems and so on. Like solar system, no moons, non-moons. Look at this. Look at the complexity of this running in your computer. But there's one that is just Earth and Moon. Yeah, so this is Earth with an even more accurate precision, more accurate simulation, I believe, of it. It has, I think it's simulating, isn't it simulating the climate? Or there is an experiment for that as well. Anyways, and this is our moon. Look at the moon. Let's check the moon. We know that guy. So again, you can change all aspects of this. An example, we could add a real life object. We could add a tennis ball. We could totally add a tennis ball somewhere around here. So that's our tennis ball planet, right there. We're just leaving it static here. We're not doing anything. Well, basically density, in case you're wondering, mass is how much materials there are. The radius is how large it is. And the density is the ratio between mass and radius, right? The higher the density, the more materials in the same space, in the same area, right? So that's basically what's going on here. And we're gonna just, I guess, press play and see what happens. We're basically gonna slow down moon. That's gonna whoa, chill. That's kind of fast. Wait, can we do it like on a side? I'd love to do it on the side of it. Like just hit it, but like on the side. I don't know why, but I want to do that. Okay, yes, that's happening. That's happening. Let's check this. Let's check the temperature. The temperature is, oh my god, the temperature is, oh yes. Oh, look at this collision. And oh yes, it is happening. That's a thing. Oh, okay, we just made a, look at all the particles that are still going around the moon, because the moon, well, sort of gravity. It does have gravity, by the way, in case you've forgotten. It's not huge, but it is. All mass has gravity. You even have your own gravity, although it's so tiny, really. Who cares? Look, we made it a terrestrial planet. That's all we needed. We just needed a huge tennis ball to make Moon a place where we could actually live. That's amazing. Speed it up. I guess this is gonna go back to normal eventually. Oh, look at this! Just a bunch of fragments. Oh, look at the fragments. Now they're wandering off around. They're orbiting Moon. Oh my god, we set it off course. Look at the curves of the Moon. But it has particles, fragments orbiting. What if we make it? Oh, look at the fragment. We're gonna bring this fragment closer to Earth, and we're gonna make it out of orbit. There we go. So the moon has all its complexity going on there, but we have our little fragment that is now orbiting around the Earth. We can actually change the fragment. We can do all sort of things. We can actually, well, play with this. So, okay, we can increase the water. We can plasma. Interesting. We can add a little hydrogen, just a tiny bit. some iron because I saw Earth have some. And this is all, you know, sorry again, physicists, sorry again, everybody. I apologize to everybody. Just, I apologize. Look at this. It's already shaping up. Let's give it some more mass. Some more mass. It needs mass to be something. So we're gonna make it compared to Earth. Let's make it 0.1 Earth. That is quite big. Let's speed it up. We're going there. Okay. Oh, it's cooling off. It's cooling off. Oh, it's a terrestrial planet. Our little fragment is now a place where maybe eventually life could exist. Let's compare these two. Shall we for a second? How much water? Oh, there is so much water compared to Earth. Really. Okay, we're gonna switch that. Okay. Okay. And yeah, I wish we could have atmosphere and all that. I'm not sure how to get that going. But anyways, there's okay, yes, I totally did it. I totally nailed it. I nailed it. There's too much water here. Wait, no, I got this. Okay, there we go. We go. A little bit more, a little bit more. Okay, there we go. Okay, there we go. There we go. That's some sort of planet. That's a, thank you. You're welcome, guys. You're welcome. I know, I'm awesome. Look at the moon. We just completely lost the moon. Completely lost the moon. It still has some ooh, look at the fragments. Look at the fragment. Oh, whoa, 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 whoa. Do you see that? Do you see the crater of our explosion? That is awesome. That is awesome. There's a lot of texturing going on here. Oh, that looks good. That is our tennis ball right there, guys. So basically, we can shoot things to it. In case you were wondering, let's see. Let's find something to shoot the moon. A Pluto. I need comparison of size just to. What's your radius? Okay, yeah, you're gonna be fine. Look at the texturing. Look at the texturing. Isn't it cool that it's doing all that, simulating all that? It's not just fancy, it is fancy, but it's simulating all that process at the speed you set it. That is the interesting thing. We can speed it up again. Isn't it cool? And you can play with this all you want. But I'm really wondering if, you know, shouldn't the mass combine? Something that I don't think it can simulate is the creation of the moon and Earth, right? Given that the moon and Earth is said to be, you know, explosion, well, you know, they split and then, well, I made a really, really interesting thing going on. Well, because it's really warm, that's why. It's gonna stop looking like this in a few hours. Just a few hours. Or a few days, but look at the temperature just dropping. But yeah, no, it really is interesting to play with this, and we can actually do a bunch of other experiments, and I actually been doing that. So let's take a look at that footage. The Earth between two suns. Let me slow this down for you. Yeah, it starts at an awfully fast speed for no reason. So you can see it's only dark here. Why? Well, because you got a sun there. And another one there. It's cool to play with this stuff because you get a good sense of... What is a tennis ball here? It's not clickable, so it's just a glitch probably. Can I move this? Wait, hold on. Can I move the tennis ball? No. Can I move Earth? Oh, we totally move Earth towards the tennis ball. Well, since, yeah, the tennis ball is a glitch. It's still alpha, so, you know, whatever. But, you know, I removed it from its center, so I'm guessing that eventually, in many, many, many years, this should eventually... Okay. Just... Okay, and we destroy Earth again. Because now it's so far from the suns that, you know, whatever. Oh, the zooming, it takes so long. Because it's all dark because, you know, there's no light, but you can see it here. Yep, I kill the Earth fairly often. Jupiter between two suns. This is interesting. These are all funny and interesting, not funny, very interesting experiments to do. Oh man, look at this. And let's go back to our solar system for a second. In case you were wondering what a black hole is, it's very interesting how they managed to pull off something as not misunderstood, but we barely know much about black holes. We just assume things, right? We are not going to test it, right? We cannot make observational science on it. But I can just add we're going to slow down this, and I can just add a black hole somewhere around here. And you can see that this is at 1 minute a second. 1 minute a second, that's our black hole. Look at the sun rushing. This is what if we had a black hole this close. Can you feel that? Can you feel that? Look at that. We're gonna speed it up. Gone. You were looking for explosions? No, that is a black hole. Just like a vacuum, man. It's a space vacuum. What other experiments do we have? Okay. Look at the luminosity. It's 4,000 times the sun. There's no glasses for this. Figure 8 stars. Okay, look at that. That is nicely done. A lot of patience or a lot of math involved to do that. Earth and many moons. Oh, damn. Why do I feel like I could easily break this? Why do I... Oh, okay, no, this is just breaking on its own. I didn't do anything. That's why I like to quickly add. I like that they did add some sound effects. It is important to have some sound effects. Even if there should be no, sounds, because space. So, oh, damn. Yeah, that is pretty much... So that is why we don't have that many. Yep. Next one. Climate simulation. There is a climate simulation going on. It actually shows you what happens if, well, nothing. Actually, it is like, it paints on, snow basically where it should. So that is pretty cool. It's going at 30 days a second. That is a year in about 12 seconds. That took me a while. And yeah, that is interesting. That is interesting doing the climate thingy. I can tidally look at. And now it's gonna be always facing the sun, I think. No, yep, it's always facing the sun in the same spot. So you can see how every year more and more ice just covers the earth on the area that never gets sun. That's a little 2012 for you. Simulated 2012. And it's way better than the movie. Let's what was one that was really interesting, I think. You can see it's moving slowly. Yeah. And okay, let's just do it all the way. Let's make a really big thing. Let's make it 5,000. Too much hydrogen, I'm thinking. And water, maybe water? No? Okay, no. How about iron? How do you feel about iron? Organics, carbon, any? No? Okay, cool. And okay, let's start moving. Okay, this is now moving at 2 minutes a second. One huge planet right next to Earth, guys. One huge planet right next to... Oh, that's gonna collide so badly. Oh my god. Oh my god. Oh my god. Oh, it's colliding, it's colliding. Ah! Oh, damn. Damn. And we're gonna change the name to was Earth. Damn. Oh, look at that. So yes, this is nerd fun indeed. Galaxy collision. This is just fancy to look at, there's not an actual galaxy here. It's just a bunch of particles, but that works with me. It's basically like a big particle collision, and this is running at ideally at 1,000,000 years per second, as you can see right here at the bottom. But I think because I'm recording now, it's not doing it. But you know what? We can just deal with it at half million years a second. Is that fast enough for you? This is the game that runs faster, if you may. Look at this. Look at this. What a mix of gravitational crap going on here to have these two just grouping of everything, of stars and planets and everything, just eventually go through each other. It is fairly interesting. We are 30 million years into the simulation now. This is how long it would take. 30 million years. 30 million years. It took you 10 years to do high school and all that. And this is 30 million years, 40 million years. Get a perspective, would ya? What happens if I add a black hole, by the way? Now I'm interested in adding a black hole everywhere. I added a black hole. I don't think they care. I don't think they care, or this is not part of the simulation either way. Oh, this is so detailed. Oh my god. Yeah. Okay, now we're running at 5 years a second. Can we reduce the accuracy? Okay, and that's the black hole. Bye, black hole. It's completely expelled. Now we're gonna look at this. Look at this. Isn't it cool? Oh, I should have reduced the accuracy a long time ago. Sure, you want it to be more accurate, but still. Okay, I think I screwed it up with the black hole. Clearly, I screwed it up. I love to scrub space. And Earth versus asteroids. There's my buggy tennis ball again. Yeah. Indeed, that is a fairly good representation of that would happen. I just love to look at this. It is extremely, you have no idea, just playing with all this and tweaking things. I'm not gonna do that. Supernovas, let's check one of the supernova close-up real time. Oh, this is 1 second per second, real time. They are aware that is an interesting point of view, you know, real time in space. You can see how fast a supernova is. It even looks like slow motion, but if you just think at the speed this is growing, it's just insane. Okay, well, this is not gonna last much. You can see Earth just rushing at, we're simulating at 2 minutes per second. It's just rushing towards sun because it's so close to it. You can see all the hydrogen, I think it is, just bursting out of the planet, just aiming towards its inevitable destruction. So yes, Universe Sandbox, ladies and gentlemen, currently available as an alpha version. You can actually buy it at their website. You can find the link in the description below. And it is fairly interesting and really fun to play with it. It's sure not a game, but it makes you like really want to experiment and try things and see what if, right? What if I did this and just tweak with things? And I do find that just really interesting. Just to be able to do all that, it's just I'm glad to see that people still make this kind of stuff, right? And it's not just cow clickers. And instead they're like, you know what, we want to simulate the universe and play with it. And this is really what it is. Now you can just play with things, you know. This is a really nice picture, by the way. And yeah, that is pretty much it. Universe Sandbox in a nutshell, but there is so much more you can do with it. It's insane because again, it's simulating all physics and so on the universe. Not just making it fancy, it's actually simulating what's going on, the gravity, with, you know, with the mass of the sun and so on. It's doing all that. That is what's really interesting about it. And it's not just you know, an orbit simulator, if you may that said. It's simulating many things. So, you know, if you're into physics, especially space, if you like space, this is the game for you. This is the software, the tool, or the sandbox for you. And if you just like simulation, you're still gonna find this interesting. I mean, I'm not into physics that badly. I like physics, but not that badly. And I still had a lot of fun, literally, by playing with this, learning things. I started to learn more things. And actually, the first game that got my dad interested. That's what I needed to tell the developers of this game. That is insane. For him, video games is Mario Bros. 1990 something or 1980 Mario Bros. Sorry, and that is video games for him. And this is like, oh, they are actually interesting. Yes, they are. There's simulation. Simulation is super interesting in video games, and this is a fine example. No game mechanics whatsoever, but a beautiful sandbox to play and see what happens when you do things. Like an example, whenever you change, what happens if you change the mass of the sun to, well, twice its mass? Happens that. Way before you even reach there, by the way. And yes, that has been all, and once again I destroyed the universe. So thank you for watching, and I'll see you next time. Oh, this is the most satisfying thing ever. We are God in SimCity 4. Wow, that was loud. Oh, you're gonna eat that, huh? You're gonna eat it. I see. What? Nothing. Okay.
And now she is tossing that salad with her... Stop sticking your finger in your ear! Alright, she's tossing the salad with her earwax.
It does.
Yeah.
It does.
It doesn't really well. Okay.
Oh, they're coming for you, Pablo!
Shit!
Run!
Oh, yeah. These road trips, man, are killing me. Anyway, let me know whenever we are recording. Hi, and welcome to another episode of Extended Play. I'm your host, this is Stuart, and that is a fancy sign. Thank you for watching, I'll see you next time.